In this topic, we begin our discussion of functions, particularly as they appear as sets and maps. Now, a little word about motivation. This new concept that we're introducing, functions, is very important. Functions help scientists, engineers, and mathematicians translate physical phenomena into mathematical objects. You and I use functions every day without even realizing it. As you continue in math, you will study functions deeply from the mathematical perspective. And as you continue in your specific field of study, functions will be at work behind the scenes, helping you whether you realize it or not. Now, before we get into the technical definition of a function, we first have to define a slightly more general term, that is, a relation. Let's proceed with the definition. A relation is a set of ordered pairs. Now, what are ordered pairs? Recall, ordered pairs are pairs of elements, and we write them with a parentheses notation, remember? Where you have your first coordinate, which we call our x-coordinate, and then our second coordinate, which we call our y-coordinate. This would be an ordered pair. So a relation is simply a set of ordered pairs. For example, the set that contains the ordered pairs 0, 1, 2, 8, negative 3, 5, negative 4, negative 10. This is called a relation. Now, there are two specific things in the relation which are important. The domain of a relation is the set of all x values in the relation. In other words, the first elements are all called elements of your domain. So, in your set example, we would say that 0, 2, negative 3, and negative 4 all make up elements in the domain of the relation. The range of a relation is the set of all y values in the relation. The second coordinates, the second objects, these are all elements of what we call our range. So in our specific example here, 1, 8, 5, and negative 10 would all be elements of our range. Relations are meant to express a correspondence between these two variable quantities. The domain, which represents the possible values of the first quantity, also called the x values or input values, and the range, which represents the possible values of the second quantity, also called the y values or the output values. So basically, you can think of a relation as a correspondence between your inputs, your domain, and your outputs, your range. Relations come in all different shapes and sizes. In mathematics, the relations that we are going to look at will most likely be expressed as sets, maps, graphs, and equations. In this specific topic, we will focus our attention on relations which are expressed as sets or maps. For example, this relation R, consisting of this set of ordered pairs, is a relation expressed as a set. It describes a correspondence between x values and y values. Look closely at these ordered pairs. Can you see how the x values and the y values correspond? Notice that each y value actually is the square of the x value. 9 is 3 squared. 16 is 4 squared, etc., etc., etc. Here's the same relation expressed as a map. In a map, the arrows start at the elements in the domain, and they end at elements in the range. Recall, the domain is your set of x values. So for this specific example, the domain would consist of your points 0, 1, 2, 3, 4, and 5. The range is your output values, your set of y values if you like. And in this specific example, the outputs are 0, 1, 4, 9, 16, and 25. Again, notice the correspondence described here. Each element in your range is simply the square of the element in the domain. This is just one specific example of a relation expressed both in the form of a set and in the form of a map. Let's now take a closer look at relations and then how they apply to our more important topic of functions. Now, the one problem with relations is that the definition of a relation is very general. The concept of a relation is meant to allow us to express any possible correspondence between two variable quantities, any correspondence, any set of ordered pairs. Unfortunately, our brains are limited, and most relations are simply too complicated for us to comprehend. For instance, let's just take a simple correspondence, a relation between a domain and range, where every element in the domain maps to every element in the range. Even this becomes very messy, even when only considering 9 elements in our domain. Therefore, in mathematics, we have developed a different concept that helps us to describe relations that don't get too complicated. This is where our concept of functions come into play. This brings us to the definition of what a function is. A function is a relation in which each x value corresponds to exactly one y value. Let me restate. A function is a relation in which each element of the domain corresponds to at most one element in the range. The concept of a function, therefore, is meant to describe a straightforward correspondence in which each input, x value, may only have one output or y value. For instance, consider this example. The mapping on the left describes a function, whereas the mapping on the right does not describe a function. The relation here has each element of the domain mapping to a single element in the range. Whereas, in this example, with this relation, the elements in the domain map to multiple elements in the range, therefore creating something that's not a function. Therefore, to determine whether a relation is a function, we must examine every x value in the relation and make sure it corresponds to a single y value. Recall that the domain of a relation is the set of all x values in the relation, and the range of a relation is the set of all y values in the relation. So a function is a relation that takes every element in the domain and maps it to at most one element in the range. Let's work some examples together. Example 1. Determine the domain and range of each relation, then determine if the relation is a function. We begin with the relation expressed as the set 2, 9, 22, -2, 36, 9, 2, 7, 52, 7. Let's start by identifying the domain and the range of the relation. Recall, the domain is the set of inputs, your x values if you like. So in our relation, our domain will simply be the set of the following values. Let's underline them. 2, 22, 36, 2 again, and 52. We don't need to write that 2 twice. So when we write them in our domain, we'll have 2, 22, 36, and 52. This is the domain of our relation. Let's now talk about the range. The range is the set of y values, the outputs if you like. The range for our relation consists of the second coordinate in the ordered pairs. 9, -2, 9 again, 7, and 7 again. Numbers that appear more than once, you don't need to write them more than once. So we simply have -2, 7, and 9 being the elements in our range. Does that make sense? Now, we have to determine if the relation is a function. And it's a function if each element in the domain maps to at most one element in the range. Therefore, we focus our attention on our domain. Is there an x value the domain value that maps to more than one y value. Notice 2 appears here as an x value and here as an x value. This means that 2 maps both to 9 and to 7. This is an element of our domain that maps to more than one element in the range. Therefore, this relation is not a function. It is simply a relation, so we can write it as such. Relation, but not a function. And the reason it's not a function is because the value 2, an input value, maps to more than one output value. Let's take a look at example 1b.